In today's lesson, we are talking about all kinds of things about quadrilaterals, so figures with four sides. We're going to talk about the definitions. We're going to talk about properties of each. So if you know it's a parallelogram or you know it's a rectangle, then you also know these things. And we're going to talk about going the other way. Or if you don't quite have everything for the definition, are there other ways to show that it's a rectangle or a rhombus or whatever? So a lot of things to put in our formula list. Starting off in our regular notes, just some definitions. As you know, quadrilaterals are shapes that have four straight sides. A trapezoid has one set of parallel sides. Usually we draw it with the top and the bottom. A parallelogram, both sets of opposite sides are parallel. And that's definition on parallelogram. Then we talk about some special parallelograms. So by definition, if it's a parallelogram, so one way to prove that it's a rectangle, top and bottom are parallel, left and right are parallel, and one angle is a right angle. That's enough for it to be a rectangle. Properties are going to come out that all four will be, but all we would have to prove for definition would be two sets of parallel sides and one right angle in there. The next special parallelogram is a rhombus. So all we have to have for that definition is that the top and bottom are parallel, the left and the right are parallel, and if we simply know two adjacent or consecutive sides are congruent, that's enough that all four sides are going to have to be congruent, which is what we usually think of for a rhombus. So if we needed to prove that it was a rhombus, we'd have to be given or be able to show top and bottom parallel, left and right parallel, and two sides congruent. We wouldn't have to go through and show first side is congruent, the second side is congruent, the third side is congruent, the fourth side would be a little bit shorter than that. And the final special parallelogram is a square, and it is both a rectangle and a rhombus. So it is a parallelogram. It has a right angle, and we know two consecutive or adjacent sides are congruent, and that is enough to have met our definition of it being a square. And then we're going to move into all the special other properties of these things. So, definition of a parallelogram is top and bottom are parallel, left and right are parallel. If you know it is a parallelogram, you are also going to know some other things besides just this definition piece. One of the things that you are going to know is that your opposite sides have to be congruent, and we're going to put this in your formula list. And I would say draw yourself a little picture at the first one of these. Those opposite sides have to be congruent, left and right, top and bottom. And if you want to save a little bit of writing and just do the congruent symbol instead of writing out the whole word, that's fine. Or if you want to abbreviate opposite and just write OPT or something like that, as long as you know what it means, you don't have to write down every single thing. Now for these next ones, I'm going to suggest you don't copy all of that. Just do some ditto marks to show these are all about your parallelograms and save a little bit of writing. I'm going to be going back and forth with these, so we're going to come back to this and fill it out in a moment. So in addition to the opposite sides being congruent, it is also going to be true that if I take my opposite angles, they have to be congruent to each other. And I could get there by extending my parallel lines and doing combinations of corresponding and supplementary angles and all of that to be able to verify this. So that is going to be our second property, that both sets of opposite angles are congruent. And if you want to use the angle symbol, that's fine. If we draw the diagonals connecting the opposite corners, does it look to you in this particular picture like the one with the positive slope is longer than the one with the negative slope? The way this one's tilted, it looks longer going from here to here than the other one. And that's true. They usually are not the same length in a parallelogram. However, they cut each other into equal pieces. So this piece and this piece are congruent. This piece and this piece are going to be congruent. The diagonals cut each other in half. The diagonals bisect each other. And the last property for the parallelograms comes from, if I were to think about these lines going farther, that top green one with 2 tick marks would be a corresponding angle to the one that I just drew, right? So that top left and bottom left would have to be supplementary. The 2 tick marks plus the 1 tick mark has to make 180 degrees. So that's all that our last property says, is that if you pick any 2 consecutive angles, the 2 on the left or the 2 on the top or the 2 on the right or the 2 at the bottom, they would have to be supplementary. Okay, moving on then to our first special kind of parallelogram, which is a rectangle. First off, it is a special parallelogram. So our first property is everything about a parallelogram. The definition, the opposite sides are parallel. All of those things that we just wrote down. The opposite sides are congruent. The opposite angles are congruent. The diagonals bisect each other. Consecutive angles are supplementary. That is all also true. But we have a couple of extra things. We have the definition of the rectangle, that it was a parallelogram with 1 right angle. But we also know any 2 consecutive angles are supplementary. So this bottom left and top left are consecutive. They have to add up to 180. So if the bottom one is 90, this has to be 90, or they don't make 180. The top 2 are consecutive. They have to add to 180. If one is 90, the other one is 90. The 2 on the right are consecutive, so they have to be supplementary. If one is 90, the other one has to be 90, so that they add up to 180. So our next property of a rectangle is that not just 1 by definition, but all 4 angles have to be 90-degree angles, which is basically what you've known since kindergarten, 1st grade, whether you use 90 degrees or not. You knew that about the shape of the angles. Now, with a rectangle, we have something special going on with the diagonals. We know these 2 have to be the same. We know these 2 have to be the same. We know these things bisect each other. And let's see, which way do I want to actually show that on this other one here. Also going to bisect that, so those all have to be congruent. So if I then want to look at this triangle, it has one tick mark, two tick marks, 90 degrees in between, SAS. If I look at this triangle, it has one tick mark, two tick marks, and 90 degrees in between. So those two triangles are congruent by SAS. That means CPCTC, the hypotenuses are corresponding sides and have to be congruent. So now those diagonals are just as long as each other. I don't have one that's longer than the other one. So that's my final special property for a rectangle. The diagonals are congruent in that. And then we get to move on to a rhombus next. So a rhombus is a parallelogram, but it's not necessarily a rectangle, but it is a parallelogram. So all of those things that are true about a parallelogram are also true about a rhombus. And I draw a little rhombus here. I think I forgot to draw one on the rectangle set. I just find it helpful to have something here to catch my attention real fast as I'm going through those. So with a rhombus, everything that's true about a parallelogram is true. So my opposite sides are congruent with the parallelogram. Definition of a rhombus, two consecutive sides have to be congruent. Right, Rhea? So that means this one also has to be one tick mark, and this one also has to be one tick mark, and that's what we're used to being true for a rhombus. All of the sides have to be congruent. Now let's think about these diagonals. So I know that those diagonals bisect each other, right? So that and that have to be the same. This and this have to be the same. So does everybody see four little triangles in there? All of them, one tick mark, two tick mark, three tick marks. So SSS, all four of those triangles have to be congruent. Would everybody agree? Okay, so I've got four congruent triangles. Now let's look at some of the corresponding angles. Across from one tick mark, I have this angle right here. Across from one tick mark, I have this angle, and this angle. So those must be corresponding angles. So they have to all have the same measure. If I put all four of those together, though, how many degrees do I have, everybody? So each one is 90 degrees. So not just congruent triangles, but congruent right triangles. And it is a rhombus. Which also means that those diagonals are perpendicular, that they make right angles. And then I'll go back to the picture to talk about that fourth property in there. The diagonals bisect their original corners of the rhombus. So if we come back to this picture here, if I take across from two tick marks, I have this angle, and I have this angle, and I have this angle, and I have this angle. Those are all across from the two tick mark sides, right? So they have to be corresponding angles, so those four all have to be congruent. If I go across from the three tick mark side, I have this angle, and this angle, and this angle, and this angle. So what this property is saying is These two pieces have to be congruent. These two pieces have to be congruent. This diagonal bisects those original corners, and same for the other one that I already have drawn up here. So any questions with those properties before we move on to a square, our final special parallelogram? Moving on then to the square, it is a parallelogram, so it has all the properties of a parallelogram. It is a rectangle, so it has all the properties of a rectangle. And it is a rhombus, so it has all of the properties of a rhombus. So everything about a parallelogram, a rectangle, and a rhombus. And only one more for a square. You will be very relieved to know that. So, if it is a square, then it has to have all of those properties that it just had for a rhombus. So we had to be dividing this into two equal halves. Because it's a rectangle, the diagonals are congruent. So that means if I take two congruent things and cut them each in half, I've got four congruent pieces. Because it's a rhombus, I already know these are all right angles. So then these would be some other side here. So I still have four congruent right triangles, but there's one more thing about those triangles. If they have two sides that are the same, what kind of triangle are they? And that is our final property for the square, four congruent isosceles right triangles. All of these things so far are, if it's a parallelogram, what do I know? If it is a rhombus, what can I say in my proof? If it is a rectangle, what can I say in my proof? We're about to go the other way. I don't know for sure if it's a parallelogram or for sure if it's a rhombus. Do I have to prove everything in the definition to get there? So for this section of our notes, if it is a parallelogram, I could, or if I want to prove it's a parallelogram, I could do it by definition. I could show two sets of parallel sides. But maybe I don't have enough information to be able to say that in my proof. So something I could do instead, I could say both sets of opposite sides are congruent. That's enough for it to be a parallelogram. If I don't know anything about parallel, but I can show that the opposite sides are congruent, that's enough to say it's a parallelogram. Or maybe I just know about one set of sides, and I know it's parallel and it's congruent, and I don't know for sure about the other set of sides. Or if I know it's got four sides and I know the diagonals bisect each other, then it is a parallelogram. And the last one for that group, if I know both sets of the opposite angles are congruent, that's enough for it to be a parallelogram. And again, it's kind of like with congruent triangles. We don't have to satisfy the definition of all three sets of angles, all three sets of sides. We've got some shortcuts, some other ways to say they're congruent. We could satisfy the definition, or these are some other ways to say that it's a parallelogram. For a rectangle, we could satisfy the definition. We could say it is a parallelogram and one right angle. So we could do any of those ways of saying it's a parallelogram, plus we know it's got one right angle, and that would be enough to say that it's a rectangle. Or we could know it's a parallelogram, and we could know the diagonals are congruent. That would mean it has to be a rectangle. Or we don't have to know if it's a parallelogram, but if we know it's got four sides and four right angles, that's enough for it to be a rectangle. And that would be another way that we could prove that. So then we come to, for it to be a rhombus. And once again, we could prove that it's a rhombus if we satisfy the definition. So we could have enough information that we can say that it is a parallelogram and it has two consecutive congruent sides. Or maybe we don't know all of that, but we could say it's a parallelogram, and instead of knowing the consecutive congruent sides, we could know one diagonal bisects the two original corners that it connects. Or we might not know it's a parallelogram, but we see we've got four sides and we have two diagonals, and if they bisect each other and are perpendicular, that's two things, 90 degrees and bisect each other, that would be enough to say that it is a rhombus. So let's practice this a little bit. Now, you had a lesson where you're doing way too much writing. That's just the way this lesson is in the Saxon book. The nice thing is there will be some problems where you're not going to have to do a whole lot of writing. Problems that might look something like this. So look at what all you've written down. Don't put it away. We've still got more that we're going to be adding to that. So we've got diagonals that are not congruent. So let's first think, which ones did you just write down? The diagonals do have to be congruent. Which ones have you just written down and said that the diagonals must be congruent? Mason?
Square and rhombus.
So for a square and for a rhombus, do they have to be congruent for a rhombus? Do we have that on a rhombus? Because I could have a rhombus like this. That one looks longer to me than the other one. Others think. What are you thinking, Anna? So a square and a rectangle, the diagonals have to be congruent. Thumbs up, thumbs down. Is that making sense of what we just wrote down? So if they aren't congruent, they can't be the rectangle or the square, but could they be different on the rhombus? And what I want you to write down, please don't write just C and don't write just rhombus. I don't remember which way the keys are, so please write C rhombus. That's not going to kill you. That's still a tiny bit of writing. Okay, another one. Got 3 out of this group, and then we'll do some things about trapezoids. Okay, now the diagonals are not perpendicular. So now look at those notes. In which ones are the diagonals perpendicular? Which ones make right triangles in there, Dylan? So everybody good? Thumbs up, thumbs down. Square and rhombus sound right? So if the diagonals are not perpendicular, it can't be a square or a rhombus. Could they be not perpendicular with most of your regular, ordinary rectangles? Let me look at my picture on that if I can find it. Does that look like they're perpendicular? No, so it makes sense to us that we can have rectangles where they aren't perpendicular. So for that one, we would just write down a rectangle. Okay, now this one, the diagonals are congruent. So what did you just tell me? When the diagonals are congruent, what shapes could that be? What? So it could be a square. What else? And a rectangle. So It's got to be a rectangle, right? Squares is a special rectangle. So must be a rectangle and maybe a square. So if it must be a rectangle, do all four sides have to have the same length? Now, might be, but doesn't have to be. Diagonals are perpendicular bisectors of each other. Are they perpendicular if it's a rectangle? No. Are all four angles 90 degrees? So that one you're just going to write C. You don't have to write the whole sentence out. Make sense to everybody? All right, moving on to trapezoids. We need to talk about a little bit of vocabulary with trapezoids. So trapezoids, we know by definition, have one set of parallel sides. Usually we draw it where the top and the bottom are parallel, but it could be turned sideways and be the left and the right. Whatever the two parallel sides are, we call the bases, and the ones that are not parallel are called the legs. That's color-coded. The ones I've got in black are the bases, the ones in green are the legs. Now I've got that new line through the middle there. This line through the middle is taking the midpoints of those two sides. So those two pieces are congruent to each other. Now this green line doesn't look as long as the one on the left, but that's the midpoint of it. Those four pieces aren't all the same as each other, but the two on the left are the same as each other, the two on the right are the same as each other. And we call that line the median. And a couple of special formulas for a trapezoid. You know the area formula, 1/2 base 1 plus base 2 times the height, or base 1 plus base 2 times h all over 2. I think of that as the average base times the height. Because take two things, add them together, divide by 2, that's the average. So b1 plus b2 divided by 2, that's the average base. Personally, I use the formula the form on the left if I have fractions. If b1, b2, or h are fractions, I use the one on the left, and I use the one on the right if I don't have any fractions. They both work either way, but if I start doing fractions inside of this fraction, I get messed up on my arithmetic and get the wrong answers sometimes. So that's what I do, but you're welcome to use either way, whatever makes the most sense for you. Now that cool line that we just drew, called the median, is just the average base. It is everything out of that area formula except for the height. And then after this, there's only 4 more formulas, and they're all about special trapezoids. So the special trapezoid that I want to talk about is an isosceles trapezoid. I guess I didn't get altitude or height labeled in there. When you're doing that in that area formula, that's got to be at a 90-degree angle. It might be one of the sides, but only if one side is perpendicular to the two bases. The special trapezoid that we're going to talk about is an isosceles trapezoid. So we still have the parallel sides, but what makes it an isosceles trapezoid is the two legs are congruent to each other. So it's kind of like an isosceles triangle with the top chopped off. The lower base angles are the ones at the bottom, the A and the D. The upper base angles are the ones up at the top. Now, the special thing about the isosceles trapezoid, if we did think about this as an isosceles triangle with the top cut off, we know these base angles would be congruent to each other, right? Because the top and the bottom are parallel, this angle on the left has to be supplementary with the angle on the right. This angle down at the bottom has to be supplementary with the one up at the top also. But if the bottom ones are congruent, these have to be congruent. So what I'm going to be able to say is I can take one of the lower base ones, and either B or C is a supplement. Same thing if I started with D, so that gets us our properties on our special isosceles triangle, that the upper and lower base angles are congruent to each other. And this last one, that either one of the bottom ones is supplementary with either one of the top ones. The other special property in there is that the diagonals will be congruent. So if I came back to my picture here and I drew in my diagonals, I could do my similar triangles again with the whole, and get that those two diagonals would have to be corresponding sides, so they'd have to be congruent. So, are we still getting these copied down? Let's get that going. So with this trapezoid, we're trying to find x. Start by writing down the formula, and then plug in the things that you know. If we know that the area is 175, so what if that's on the left of the equal sign? Put it in where the A is. 1/2, B1 and B2 have variables in them, so we can write down x plus the 2x plus 8, and the height is 10. So you guys head start. Beat me to the answer. Solve that for x. I'm going to multiply 1/2 times 10 first, so I'm distributing the 5 to the 3x plus 8. Subtract the 40. What do you guys have for x? Everybody shout it out. What? So x is 9, and our units are centimeters. So we just use the formula and plug in whatever we know. Similar one, this one has the median in here, except for that one didn't get cleared before. So for this one, we are going to start by writing down our median formula, that the median is base 1 plus base 2 times 1/2. And write that out. Don't try to do it all in your head. The 2 minus the 2 will cancel. So I have 1/2 times 9x. Multiply both sides by 2. 8x plus 2 is 9x. Subtract 8x from both sides. And x is 2.